Today, we're going to be looking at this study that looks at cloth masks, surgical masks, KN95s, and N95 masks for people that are actively infectious with COVID and how well it works as source control, which means how well it prevents people from spreading the virus to other individuals. So, this is a controlled human study where they looked at the COVID viral load of exhaled breath in volunteers that have an active COVID infection. So these are human volunteers, there's 44 of them, and they have paired samplings. So this is testing unmasked and masked individuals within the same person. So I would be testing, if it was me, if I was a volunteer, I would just be breathing normally. They'd take the viral load from that. I'd put on a mask. They'd take the viral load from that and then compare the two. That's what the paired testing is. And then importantly, the most interesting part of the study is that all masks and respirators, so this is N95s, significantly reduced exhaled viral load without fit tests or training. So these are self-selected masks that people took and put on their faces, and these are highly effective, especially a duckbill N95. So without fit testing, without training to have prior experience of selecting out a great mask, just going off, this one feels good on my face. A duckbill N95 reduced the exhaled viral load by 98% in actively sick participants, which is huge. Additionally, if you're ever given the choice between a cloth mask and a surgical mask, you should pick a cloth mask because these also outperform surgical masks. So why is this important? Well, when people get sick, we want to break the chain of transmission. We don't want the sick person to get other people sick. That's how viruses can continue to mutate and continue to evade our prior immunity, is by letting people get sick and get others sick over and over and over again without any prevention of this or protective measures. So putting a face mask on a person, particularly a respirator, so an N95, limits the amount of exhaled viral respiratory pathogens or aerosols that are emitted from the person. So you're spreading less in the air because the respirator is actually capturing these because it's well fit against your face. And it has these nice electrically charged loose fibers that will catch the pathogen, and this is known as source control. And it's because of this we really want N95 respirators to be the standard of care in healthcare settings, not surgical masks, because surgical masks are good for droplet transmission. These are heavy particles that come out of your mouth like spit, but they're not good for aerosols. They're not good for the very light particles that you can't necessarily see but still exist in the air. Like when you sneeze, there's a cloud of smoke, you'll see some of the liquid goes out into the air and some of it falls down. The WHO calls this a puff cloud model, and that stuff that lingers in the air, that's can get people sick. Now, how was the study performed? So between June 2020 and December 2021, volunteers were assigned to wear either their own mask, which was mostly cloth masks at the time, if available, or a surgical mask that they provided, which was from Kimberly-Clark. And then they'd take those paired samples, so having the no mask sample and then the mask sample. And to get these, they would have them count the alphabet and then sing happy birthday loudly 3 times, or they were asked to shout go Terps 30 times. So they did all these types of high expulsion, high particles going out into the atmosphere type of scenarios, and that's how they had volunteers produce viral particles. But then in December 2021, they stopped testing cloth masks and then instead introduced KN95 respirators from their supply of Powcom KN95s being distributed on campus. And then starting in March 2022, they had inexpensive duckbill masks, N95s, from ACI. So these are actually the same ones that I use. They're blue duckbill mask. They're phenomenal. And as you can see, very great source control. And then they randomized their participants to either wear a surgical mask or a respirator, which was K95 or N95, at their first shedding visit until March 10th, when we stopped testing surgical masks. And then after March 11th, they only tested N95. So they have multiple time points, and then they're testing different masks at different times, and then aggregating all of this data. Now, what did they find? Well, from the results, they found that the N95 respirators, those duckbills, reduced COVID viral loads by 98%. So this is, again, compared to having no mask versus having a mask. So that's a 98% reduction. That's huge. And then the next one, it was followed by cloth masks, surprisingly, with a reduction of 87%. This was followed by surgical masks with a reduced exhaled viral load of about 74%, and then KN95 respirators, which had a reduced exhaled viral load of 71%. Where this plot sort of breaks that down for us, so it breaks it down into fine particulates. So this is the aerosols, the coarse particulates, this would be the droplets, and then the total RNA copy number. So that's it's a surrogate number for the infectious particles that would be released otherwise. So we have the initial one with no mask over here, the paired over here. And if we look at fine aerosols, we see that N95s, surgical masks, and cloth masks in this study had the best results, with N95 having the most significant reduction in the aerosols released into the atmosphere, into their surroundings. So that would be a less likely chance of getting people sick by a huge margin. And then for the droplets, again, cloth masks and N95s have huge reductions where basically nothing droplet sized is getting out. And droplets are considered like 5 micrometers. So that's very small. So you might be thinking droplets like a raindrop, much smaller than that, like very small fraction of a raindrop. And then, so the total RNA copies, that's sort of like the most important part of this. And again, the N95s, huge reductions, cloth mask, huge reductions. But surprisingly, the KN95s, not that much of a reduction. So if you're going to have a choice between an N95 and a KN95, I would definitely go for an N95. But again, these are not fit tested. So this could just be this one brand of KN95s. The Powcom might just not be effective, but other brands might be effective. So take that with a grain of salt. But again, the N95s have huge reductions. These just, they work. And then, as the authors note down here, one possible explanation for the KN95 not performing as well as one would have expected is because that these Powcom masks were relatively stiff. So because of this, they weren't like flexible. They didn't conform to the person's face as well. So they're air gaps. So that could have contributed to this. And by contrast, the cloth masks that were brought by their volunteers tended to wrap farther around the face, providing a better fit with lower flow resistance. And that's a very important point too. N95 masks have very low flow resistance. That means it's very easy to breathe through them. They're breathable. KN95s, they're a polymer-based mask, so they're going to have much higher flow resistance and going to be harder to breathe in. And depending on the cloth masks, those can be easier than the KN95s to breathe in. And then this is that same information in a different format. So this is the exhaled breath aerosol. So the number of particulates with virions in them for coarse ones, fine ones, so aerosols, droplets, looking at mask versus no mask. So the paired analysis put into a ratio. And we can see with the N95s, there's a huge reduction in fine particles. There's a huge reduction in coarse particles and overall particles of the viral RNA of COVID. But the thing is, wearing any mask is better than doing nothing. You're reducing the number of viral particles, regardless if it's a cloth mask, a surgical mask, or a K95. But when you do have a choice, you should always pick an N95 respirator mask, because that is the one that's going to be the most beneficial for you and for others.